A very good morning to all of you. I welcome you all for this engineering thermodynamics course. So in the today's class, we are going to discuss about what are the limitations of the first law of thermodynamics. So that is whenever we want to proceed to the second law of thermodynamics, first of all, we should know. So what are the limitations of the first law of thermodynamics and why we have to study the second law of thermodynamics? That is very, very important one. So the same thing I have written here under the motivation. So to proceed to second law of thermodynamics, the limitations of first law of thermodynamics should be known to each and every one. So the objective is known to you, and what is the outcome after the completion of this lecture is to explain the limitations of the first law of thermodynamics. So here I can say only the very, very important points are listed, only the 2 points are there. What are the limitations of the first law of thermodynamics? So here the first important point is it will not provide the information about the direction of the heat transfer. So it is the gist. So that is there are basically the two limitations are there. So actually I have listed as the last slide. So that is it will not provide the information about the direction of the heat transfer. That is actually we can witness that is the heat transfer will takes place from the higher temperature body to lower temperature body. So that is automatically it is taking place. That is the heat transfer is always taking place from the higher temperature body to lower temperature body. But if you want to transfer the heat from the lower temperature body to higher temperature body, always we have to provide some amount of the work input. So without any work input, so heat cannot travel on its own from its lower temperature body to higher temperature body. So that is one of the limitation which is prescribed by the first law of thermodynamics. Let us see. Let us say that is the refrigerator is there. So in the refrigerator, we want to obtain the cooling effect. So how we are able to obtain the cooling effect in the refrigerator? So that is very, very important one. That is, there are four important components are there. So that is the compressor, the condenser, expansion valve and evaporator. These are the four important components in the domestic refrigerator. So that is the heat is transferring. That is in which component you are able to get the cooling effect. So it is the evaporator. So evaporator is the actual component which is giving us the desired amount of the refrigeration effect or the cooling effect. So now the whatever that is the refrigerant is flowing inside the refrigerator. So the refrigerant will absorb the heat from the products or the substances what we kept inside the door of the refrigerator. So that is the heat is basically taken up by the refrigerant, and that particular heat is to be dissipated to the surrounding atmosphere, that is through the condenser tubes. Because everybody knows that whenever you are going through the back side of the refrigerator, we are able to see one jolly type of the construction that is known as the condenser tubes. So whenever you keep your palm or the back side of the condenser tubes, you are able to feel the sensation of the warmness. So that is the heat is dissipating from the condenser tubes to the surrounding atmosphere. So condensers are normally known as the air-cooled condensers, water-cooled condensers and oil-cooled condensers. So in the smaller domestic capacity applications, we are using only the air-cooled condensers. So that is the heat is dissipating from the evaporator to the condenser. That is from the lower temperature body to higher temperature body, the heat is dissipating or transferring. So that is how it is possible. That is we are giving some amount of the electrical input in the form of the, that is a work input, that is in the form of the electrical input. So whenever we are giving some amount of the work input to drive the compressor, so then only the heat is basically transferring from the lower temperature body to higher temperature body. But naturally, the heat transfer will take place from the higher temperature body to lower temperature body without any amount of the work input. So that's why. So the important one is the direction of the heat transfer is basically not at all given by the first law of thermodynamics. And similarly, the second foremost, the limitation is it will not give any information about the process feasibility. So that is whether a process is feasible or not. So that information is not at all given by the first law of thermodynamics. So that is whether a particular process is feasible or not. So that is whether a heat engine should operate with only single thermal energy reservoir or minimum two thermal energy reservoirs are required. So such type of the information is not at all provided by the first law of thermodynamics. So that is, if you want to have some work input from the heat engine, so automatically what should be there? That is minimum two thermal energy reservoirs should be there. So that is the heat engine that is has to be operated between the minimum two thermal energy reservoirs. That is from the source, it will take some amount of the heat input in the form of the Q1. And similarly, there should be some heat rejection. That is, there should be heat rejected to the lower temperature thermal energy reservoir that is called as the sink. So that is minimum two thermal energy reservoirs are required to produce some amount of the work output from a heat engine. That is that condition only the process is feasible. So with a single thermal energy reservoir, it cannot work. So such type of the limitations are basically not given by the first law of thermodynamics. So that's why to overcome these important two limitations, only we are going for the second law of thermodynamics. So the first one is the direction of the heat transfer. So that is the second law of thermodynamics is basically given by the two statements. One is known as the Kelvin-Planck statement and the second one is known as the Clausius statement. So these two statements are basically taking care of these two limitations of the first law. So that is the first law, that is the first limitation is the direction of the heat transfer. So direction of the heat transfer is basically given by the Clausius statement. So Clausius statement says that heat transfer always takes place from higher temperature body to lower temperature body, or the heat can travel from lower temperature body to higher temperature body with some external agency. So that is the statement which is given by the Clausius statement. So that is the first limitation will be overcome by using the second law of thermodynamics in the form of Clausius statement. And coming to the second one, it will not give any information about the process feasibility. So that is taken care by the Kelvin-Planck statement of the second law of thermodynamics. So it is basically saying that so minimum two thermal energy reservoirs are required if you want to produce some amount of the work from the heat engine, or the refrigerator or the heat pump is to be operated satisfactorily under the given temperature conditions. So then also you require the minimum two thermal energy reservoirs. One is the source and another one is the sink. So that condition is basically taken care by the Kelvin-Planck statement. So hence we have to study the second law of thermodynamics only to overcome these two limitations. So I hope the limitations of the first law of thermodynamics is clear to you, because then only you can understand what is the necessity of studying the second law of thermodynamics. I hope it is very clear. So thank you very much for attending this particular session. Thank you.